Okay, you have to let me know whether pausing it and doing this speeds us up or not. So looking at monitoring progress on page 444, you were given an explicit formula and asked to translate that into a recursive rule. So they gave you a sub n equals 17 minus 4n. Looking at that and recognizing the pattern, it's arithmetic sequence. So a sub 1, got to figure out what that is for my recursive formula. So I took 17 minus 4 is 13, so I'm starting with 13. I know my common difference from the explicit rule is -4, and so my recursive rule is going to be a sub 1 equals 13, and then a sub n equals a sub n minus 1 minus 4. For the 10th one, they gave you something that you could easily recognize as geometric. So the a sub 1 was 16, you have to figure out the first term, 16 times 3 to the 0, which is 16 times 1, which is just 16. The common ratio was 3, which you can tell from your explicit formula. So the recursive rule for this one was a sub 1 equals 16, and then the rule was a sub n equals 3 times a sub n minus 1. For number 11, this time you were asked to go from the recursive to an explicit formulation. So they gave you the first term was 12, and you can tell that it's arithmetic, and from this you know that you're going to be adding 16 to each term. So remember your general rule is a sub 1 plus n minus 1 times that common difference. So negative 12 times n minus 1 times 16. I'm distributing, simplifying, and the rule that you should have ended up with was a sub n equals 16 minus 16n minus 28. And for the last one, they gave you one that looked like it was geometric in recursive form. So they specified the first term. They told you it was -6 times the preceding term. So therefore, you know the first term already, and you're plugging into that general form for a geometric sequence, which is just the first term times that common ratio to the n minus 1. So should have ended up with a sub n equals 2 times -6 to the n minus 1 power. Look at example 6. These are the word problems. In your textbook, these are on page 445. You started off, read it, and initially contained 5,200 fish. Each year, the population declines 30% due to fishing and other causes. And so the lake is restocked every year with 400 additional fish. The first thing they asked you to do is write a rule, a recursive rule, for the number of fish, a sub n, at the start of the nth year. So when we're thinking about that, we know it starts with 5,200 fish, and it declines 30% each year, so 70% is left. And that means for any given year, I'm going to have 0.7, 70% of whatever fish I had to start with, plus 400 more. Hopefully you could tell that this is going to be a declining balance, but maybe not. So that was for A. Then look at B. They wanted you to find the number of fish at the start of the 5th year. This is recursively. So I'm starting with 5,200. And then there is a handy thing, let me get my calculator, that I want you to be able to do. It makes it a lot quicker to do this. I wasn't sure you would see from the thing that they gave you in the textbook how to do it. So if you enter, look at B, and get your calculator, and enter 5,200, because that's what they started with. So 5,200, and you pressed enter. And now to get the next one, they're doing 0.7 times the answer. You might already know how to do that, but in case you didn't, I'm taking 0.7, and to get the answer, I'm doing second, and see where the negative sign is? There's a little answer, so if I put 0.7 and click that, I get answer. And then plus 400, and that equals 40. And if I keep doing enter, 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 it will keep doing that. I don't have to keep keying it in all the time. So that's what they were trying to tell you. The answer is found second and over the negative sign at the bottom. Was a handy way to do that. It makes it a whole lot less tedious. And then for C, I'm assuming we can do those. Monitoring progress, I skipped. And look at example 7 where you're modeling with mathematics. This is another word problem where you borrowed $150,000 at 6% annual interest, compounded monthly for 30 years, and the monthly payment was $899.93. And it wanted you to find the balance after the third payment. So if we were going to write a rule for this, my monthly payment is going to be, I'm going to pay all of what I owed, and from that I'm going to subtract $899.33. The important thing is that you have to, well, so let me go back. From that 6% annual rate, I'm doing it monthly. So first I need to find what that monthly rate is, and so that's 0.06 divided by 12, and that's how they got the 0.005. It's 100% of what I borrowed plus that monthly rate. So 1.005 is the rate that I'm using for that, whatever the balance was at the beginning, minus the $899.33. Notice that they're calculating your interest before they deduct your monthly payment. And if you do that, then we're back where we were, and they've showed you, and we're good. That was this lesson in a nutshell. It was recursive. Where I want you to stress is on the explicit. That's the most important. But it's nice to be able to go back and forth. And that little calculator tip was a handy one, which would make it easy. Homework, I don't have worksheets, so this is just textbook problems, and I've listed them on my school app. And I hope we don't have to keep doing this. See you later.